Hey guys. All right, so for this video, we are going to start 6.5. And the title is called Graphs of Tangent, Cotangent, Cosecant, and Secant Functions. Okay, so the first thing we are going to try to do is, I'm going to zoom in just for this piece. I'll move over to do this in a little bit. We're going to try to graph out tangent of x. So tangent of x, we're going to find the period and amplitude. Okay, so the period, and pay attention to this. Period for tangent is no longer 2 pi divided by absolute value b, but it is just a pi divided by absolute value b. Okay, just a pi divided by absolute value b. So for our parent function, period is going to be pi divided by 1 is going to be pi. Okay. Amplitude. Remember, amplitude was, the definition was that is the average of the local minimum, I'm sorry, the average of the minimum and the maximum. Well, tangent will not have any minimum or maximum, so amplitude would be none. So that's how we find our amplitude, and that's how we find the period for tangent. Key points. Okay, remember you are to use key points for graphing. Key points are, I'm going to make an input-output table. Oop, here we go. X and f of x. Okay. I'm going to use a circle. I'm a visual learner, as you know. Okay. So here's a circle. This is going to be 1, 0. This is going to be 0, 1. This is going to be -1, 0. And interestingly, I'm going to use this point because, okay, I'm going to label this pi over 4, comma. Well, what's happening at tangent of pi over 4? It's 1, right? It's a nice, awesome value, all right? Similarly, we're going to go over here, okay? That point is going to be, you know what, let me move this 0, 1 over here. 0, 1 right there, okay? Then this point right here is going to be, sorry, 3 pi fraction 3 pi over 4. Can you see that? Oh, that's super small. Okay, let's try that one more time. 3 pi over 4, comma, -1. Okay. All right. Because of the period, it's only, okay, because of the period, it's only a pi, I would only need to use the first half of the circle. Okay. So my inputs are 0, pi over 4, pi over 2, 3 pi over 4, and then I'm back at a pi. Okay. 5 inputs. That means I'm going to get 5 output. Tangent is y divided by x. So y is 0, x is 1. Therefore, at 0, tangent is 0. Pi over 4, we know tangent is 1. Okay. You know what? That's kind of confusing, isn't it? Are you confused by how I'm labeling this? How should I label this? Let's do this. Rho 2 over 2 divided by rho 2 over 2. The only reason is, notice I'm labeling this as cosine, comma sine, cosine, comma sine, cosine, comma sine, and all of a sudden I have this angle. So let's just do cosine, comma sine. So this is, I'm sorry, this is a positive rho 2 divided by rho 2, okay, comma, negative rho 2 divided by rho 2. There you go. Okay, that's slightly better, and I'm just going to make this look better by moving this point closer. All right, there you go. So this is a negative, okay? This is a positive. Oh, shoot, I just got that switch. I'm sorry. This is a negative in the front, and that's a positive. Okay, now, do they all look correct? Okay, yes they are. Okay, my bad. So tangent of pi over 4, okay, this is pi over 4. Y divided by x happens to be 1. Tangent of pi over 2, y is 1 divided by 0. That is not okay. 3 pi over 4, y is going to be positive rho 2 over 2 divided by negative rho 2 over 2 is -1. Tangent of pi, y is 0 divided by -1 is going to be 0. So those are the key points. I'm going to be graphing out 3 full cycles. 2 on the right because I have space, and then 1 on the left. Here's pi. Here is 2 pi. That's 2 full cycles already. And this is going to be a negative pi. Okay. And then each full period has 5 points. That means there are 4 intervals total. So half of a pi is pi over 2. Half of a pi over 2 is a pi over 4. Look at that. So that means every single tick mark is worth a pi over 4 unit. And again, you don't have to label every single tick mark. Okay? If you have 1 or 2, so I know that, hey, this is from here to here is worth a pi over 4. I'm just fine with that. Up 1, down 1. I'm also going to go find a different color marker or pen because we are going to have some sort of an asymptote here. So the first asymptote I'm going to have is a pi over 2. It's undefined. Anytime you have an undefined, it's also asymptote. Okay? Remember what x cannot be. So now we're just going to go plot our dots. Neatly and very clearly plot your dots. So at 0, I have 0, comma 0. At pi over 4, I have pi over 4, comma 1. And then at pi over 2, we have this awesome looking asymptote. At 3 pi over 4, we have negative 1. At pi, we have 0. All right. Right now, it doesn't look like anything, okay? But if I continue the pattern, okay, because right now that's 1 full period, and it's going to look like this if I just do that. Okay. But I need to graph the entire thing, so here we go. If I continue with the pattern over here, notice how 1 is 0, 1 tick mark to the right goes up. Okay. That means the next tick mark needs an asymptote, so that's what I'm going to do. Okay. And look, now I can connect all of these. It looks like a bunch of cubic functions put together. That's what it looks like. Then over here, if it's at 0, 0, then 1 over the left, I'm going to need to go down at negative 1. Then that means an asymptote is coming next. So we have dots. Okay, make sure your dots on your assignments are very well plotted. So right now I have 2 full cycles, but because I told you I was going to graph 3, I'm just going to finish it up, okay? So after the asymptote, then I have a dot right below, okay? Then I have a dot right on 0. So that's what's happening. Then over here, okay? Over here on the left-hand side of an asymptote, looks like I have a dot that goes to positive 1. Then if I keep on going, I have a dot at 0. So that's what a 3 full cycles look like. Okay, so now we are going to answer your domain and range, and I want to make sure I can zoom out so we can see an awesome graph here. The domain is going to be all real values excluding these locations right here. So let me count these locations. This is a pi over 4, 2 pi over 4. So 2 pi over 4 reduces down to pi over 2. 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4. 6 pi over 4 reduces down to 3 pi over 2. Okay. Then similarly to the left, we have a pi over 4, 2 pi over 4, which reduces down to a negative pi over 2. So notice how I'm really excluding these right here. Okay. Well, let's look at the distance from one asymptote to another. Would you agree that there are 4 equal intervals in between? 4 equal intervals equals a period. So that's what I'm going to exclude. Domain is going to be all real numbers, not including. Okay. Pi over 2 plus pi k, where k is any integer. And of course, I'm going to test that out, okay? Integer, okay? So let's test out when k is 0. When k is 0, am I excluding pi over 2? True. When k is negative 1 times pi is pi. I'm sorry, negative 1 times pi is negative pi, positive pi, plus a positive pi over 2 plus a pi that's a negative pi over 2. That is true. I am excluding it. 1k is 2. 2, I'm sorry, 1k is 1, positive 1. 1 times pi is pi. A pi over 2 plus a pi is 3 pi over 2. So far, so good. It works. Okay. You can also do this. Notice how these are all odd numbers. Okay. You can also do pi over 2k, where k is any odd integer. Okay. The range, it goes up forever and it goes down forever. So that's going to be negative infinity to positive infinity. Symmetry, is it odd or is it even? Okay. So from the way that this is, it's reflected over the origin. So this is odd. Remember the odd function? F of negative x equals negative f of x. Okay. So what this means is that sine of a negative 45 degrees, which is down here. I'm not sine, I'm sorry, we're in tangent. Tangent of a negative 45 degrees, which is down here, which is going to be negative 1, is the same as negative 1 times tangent of a positive 45. Period, we said it's going to be pi divided by absolute value of b, which is always pi for the parent function. X-intercepts, we have it at 0, at 1, at 2. So it looks like it's just going to be pi k, where k is any integer. I'm just going to spell int for now. Y-intercept, we have 1 at 0, 0. Okay. There's no max and no minimum, therefore we do not have any amplitude. And that is our awesome looking function for tangent. Okay. And again, if I'm going too fast, can you please hit pause so you can finish writing? Okay. Now we are going to do cotangent, and I think this might be our last one for this video. Okay. Sorry for the dots. I printed my notes on the back of some scratch paper, so that's what it looks like. That's okay. Cotangent is the same, not the same, I'm sorry, very similar to tangent, where the amplitude would be none, because there's no minimum or maximum. Then the period, okay, is going to be pi divided by absolute value of b, which for a parent function would end up being pi. And let me do our input and output table over here. Key points are, okay, table, x and y. We are going to use 0, pi over 4, pi over 2, 3 pi over 4, and a pi. Okay? We just have to go all the way to a full cycle. Then the output. Cotangent, let me bring, where is my circle? Okay. Cotangent at 0, that means x divided by y, 1 divided by 0 is going to be not happening. Okay. Cotangent of pi over 4, that means x divided by y, so that's going to be positive 1. Cotangent of pi over 2, x is 0. Oops, you can't see that. X is 0 divided by 1, that's 0 divided by 1, that's going to be 0. Cotangent of 3 pi over 2, x is negative rad 2 over 2 divided by positive rad 2 over 2 is going to be negative 1. Cotangent of pi, x is negative 1 divided by 0. Not going to happen. Okay? So these are my key points. I'm going to, we have 3 full cycles. Here's first period. Here's second cycle. And I'm going to do the left one, negative left. Okay? And then go in and put in 4 equal intervals. So half of a pi is a pi over 2. Half of a pi over 2 is a pi over 4. Then just, that's it. Break every single period into 4 equal intervals. Okay? I'm going to go as high up as 1, as low as negative 1. Then what I'm going to do next is I'm going to put in asymptotes for all of the stuff that y cannot be or y is undefined, which is when x is 0 and when x is pi over 2. So 0's right here. Okay. Well, the pattern, mathematics, is a set of patterns, right? Well, if you look at this, 1 at 0, 1 at pi. So I can only assume it's going to be 1 at 2 pi because then, again, that's a period away. Then, according to the pattern, the 1 has to be another period away, the other side, okay? So those are our asymptotes. Now let's plot the dots. Pi over 4, we are going to start at 1. At pi over 2, we are going to be at 0. At 3 pi over 4, we're going to be at negative 1. Okay, and please do not do a straight line. This is, again, like a cubic function, and it goes like this. Okay. Then, if that's the case, on the right-hand side of an asymptote, looks like we are going to be up at 1, then we're going to be at 0, then we're going to be at negative 1. And then, okay, notice how that dot is not on my curve. I'm going to make my dot fatter so it can be on the curve. Okay, so that's 2 full periods. There's 1 period. Look at that, they are exactly the same, so that means it repeats. So that's 2 full periods. And then similarly over here. All right, so we're going to start up above at 1. We're going to go to 0, and we're going to go to negative 1. Okie dokie. How does that look? Okay. The dots are clearly plotted. We have our key points. Now, let's check out the tangent graph and the cotangent graph. Looks like tangent is increasing, isn't it? Cotangent is decreasing. Isn't that cool? Okay. The domain for cotangent. Looks like we are excluding when x is 0. Okay. We are excluding when x is pi, and then 2 pi, and so on, so on. So the domain is going to be all real numbers, not including 0, pi, 2 pi. Looks like we are adding a pi every time, so we're going to say pi k, where k is any integer that you would like to put in. Okay. The range, just like cotangent, it goes up forever and then it goes down forever. So that's going to be all real solutions, or I'm sorry, all real numbers. Symmetry, it is reflected. Okay. So let's check it out. If I fold it over here, is the left exactly the same as the right? If I fold it here on the y, is it the same as the right? No. Okay, because if it's the same, then this graph would be like this. Okay, so we know it's not an even function because it's not a symmetry about the y-axis. Okay, now let's talk some more. Is it odd? Is it odd? Remember, tangent was easy to see that it's odd, right? Because we have it's reflected over the origin. But is this one odd? Let's do a test, algebraic test. Negative f of some x value equals to f of a negative of some x value. Okay? All right, randomly, let's pick, what would x be? I need a unit circle. Okay. How about this location right here? Let's see, this is a pi. Let's make the reference angle pi over 6. So this is a 7 pi over 6. Okay? Randomly. So the question is negative f of 7 pi over 6, okay, equal to f of a negative 7 pi over 6, question mark. Fair, right? So cotangent in quad 3, we know the answer would have to be positive, okay? let's list our x and y coordinate for 7 pi over 6. So we are going to, let me draw a triangle. That's a reference angle, 30 degrees. Okay, 30 degrees reference angle. My triangle says if that's 30 degrees, if this is 60 degrees, this is 1, this is 2, and this is rad 3. And tangent is adjacent over opposite, so we're going to have a rad 3 as my answer. So cotangent of 7 pi over 6 in quad 3, positive rad 3. But because this is a negative f of x, so that becomes a negative rad 3 equals negative 7 pi over 6. Negative 7 pi over 6 goes this way. Whoop. Is that okay? And again, reference angle is still the same, 30 degrees. So, because I'm in quad 2, I will also end up with a negative rad 3. So that tells me that this is definitely an odd function. Okay? And that's my odd equation. It doesn't look like it, but look, these points line up with that point, those points line up with each other, and then I'm pretty sure these points will line up with another one if we have another period over here. All right, period of a cotangent is very similar to our tangent, pi, which, you know what, let me write the formula down. It's going to be pi divided by absolute value of b, okay? X-intercept looks like 1 is at pi over 2, and then it's 4 interval away, so it's going to be pi over 2 plus pi. So pi over 2 plus pi k, where k is any integer. Y-intercept, we don't have any y-intercept at all, so we're going to say none. Okay, and maximum and minimum will also be none. Okay. So how does that look? And again, I'm just going to wait for you so you can just finish copying. And if I did say something too fast or write something too fast, just hit pause. Go and finish copying, and then press play again. Okay? All right, that is the end of our video notes. We will do the rest when I see you. Have a wonderful day.